Welcome to Mathematics. Today we'll be solving the Pearson Edexcel IAL January 2023 paper of P2. Question 1 is about trapezium rule. We are shown a sketch of this graph y equals to f of x. We are given the values of x and y, and we have to find an estimate of the area from 1 to minus 1. So using the table, this integral over here would be equal to or approximately equal to half into the first value plus the last value plus 2 times all the values in between times the width or the height of each strip. In trapezium rules, we basically break this curve down into trapeziums. So we know this length, so we can break this down into trapeziums. We know the formula of the area of the trapezium. So even if we cannot use calculus over here, we can find the area pretty accurately. The smaller the width of the trapeziums, the better the estimate. If we have a larger width, something like this, the error will be greater. If we had a greater length, something like this, the error would be even greater. And if we took smaller strips like this, the error would be smaller. The approximate would be more accurate. In this case, we take values each 0.5 units. So the height over here is 0.5. This is the height of each strip, which would this is minus 0.5, this is 0, this is 0.5. so we'll have 4 strips. So we have half into the first value, which is 2.287. The last value is 2.834 plus 2 times the values in between. The values in between are 4.470, 6.719 and 7.291. Multiplied by the height of each strip, which is 0.5. We need our answer to 2 decimal places. If we calculate this to 2 decimal places, we get a value of 10.52. Now in part B1, we need to find, using our answer to part A, the integration from 1 to minus 1 of f of x minus 2. We need integration of minus 1 to 1 f of x minus 2 dx. We can break this integration down into minus 1 to 1 f of x dx minus integration of minus 1 to 1 of 2 dx. This we find from our estimate, which is 10.52. We can integrate this. We'll get 2x. The limit is 1 to minus 1, so we get 10.52 minus 2 times 1 minus 2 times minus 1. So 10.52 minus 2 minus minus 2, so 2 plus 2. We'll have 10.52 minus 4, which is 6.52. And now we need the integral of plus 1 to plus 3 of f of x minus 2 dx. F of x minus 2 is basically shifting this whole curve to the right. If we do that, minus 1 will go to minus 1 plus 2, which is plus 1, and 1 will go to 1 plus 2, which is 3. So repeating the same graph, we'll have something like this. This is at 3, this is at 1. So the area over here from 1 to 3 is the same as the area from minus 1 to 1. So this is equal to 10.52. Now on to question 2. We are told that solutions based entirely on calculated technology are not acceptable. And then we have to show that the surface area of the brick is given by this formula over here. We know that it has a width of x centimeter, the length of 3x centimeter, and the height of 8 centimeter. We know that the volume is 972 centimeter cube. So using the volume 972, we can find the height. The length is 3x. So the volume is length into breadth, length into breadth into height, or length into width into height. The width over here is x centimeters and the height is unknown. The height in this case would be 972 divided by 3x times x, so 3x square. This would come out to be 324 by x square. Now we have to find the surface area of the brick. The brick has 6 surfaces, so this and the one on the opposite side, this and the one on the bottom, both of them would be the same, and this face and the one on this side over here. So we have to find the black area, multiply it with 2, find the red area, multiply it with 2, find the blue area and multiply it with 2. The red area, we know that this part over here is x and this part over here is 3x. So the red area is equal to 3x times x, and now we want to double it, so times 2. This is 6x square. The blue area would be 3x times h, 3x times, we know that h is 324x square, so multiply that and then multiply it with 2. We'll get 1944 by x. And the black area, this length over here is h, this length over here is x, so x into 324x square into 2. So 648 by x. So the surface area S would be the sum of these 3 angles, so 6x square plus 1944 by x plus 648 by x. If we add the second and third term together, since they have the same denominator, we'll get 2592 by x. We have to show exactly that, so we can write over here that it's shown. Now in part B, we have to find the derivative of s with respect to x. So ds by dx, this would be, so s is basically 6x square plus 2592 x to the power minus 1. If we differentiate this with respect to x, we get x times 2, the previous power of x, and then x to the power 2 minus 1, so 1. And over here we have 2592 times the previous power, which is minus 1, and then we have x to the power minus 1 minus 1, which is minus 2. So we get 12x plus 12x minus 2592 by x square. X to the power minus 2 is basically 1 by x square. X to the power a is basically 1. X to the power minus a is basically x 1 by x to the power a. This is what we used over here to convert this into this, and also to convert this into this. Now in part C, we have to find the value of x for which s is stationary. For a stationary point, we have to find the derivative equal to 0. So we need the value of x for which s is stationary. So ds by dx is 0. So we have to find 0 equals to 12x minus 2592 x square. We can multiply both sides with x square, so we'll get 12x cube minus 2592. We'll get 12x cube equal to 2592. X cube will be equal to 216. Therefore x will be equal to the cube root of 216, which is equal to 6. Now in part D, we have to find d square s by dx square. So we have to differentiate ds by dx. ds by dx is 12x minus 2592 x to the power minus 2. We also have to show that the value of x found in part C gives us a minimum value. We have to note that if the second derivative is positive, we find a minimum point. This curve basically shows that we have a shape like this. If we have d square s by dx square less than 0, we get a maximum point. And in case d square s by dx square is equal to 0, we get a point of inflection. So in this case, if we differentiate this again with respect to x, we'll get 12 minus 2592 times minus 2 times x to the power minus 3. At x equals to 6, this value would be 12 plus, we can break this down further, 2592 times minus 2, this would be 5184. 5184 by x cube. We'll have 12 plus 5184 by 6 cube. This is 36, which is greater than 0. Therefore, at x equals to 6, we get a minimum point. Now in part E, we have to find the minimum surface area. We know that the minimum surface area occurs when x equals to 6. So at x equals to 6, the surface area is 6x squared plus 2592x by x. So 6 times 6 square plus 2592 by 6. If we calculate this, we get a value of 648. And we get this in, okay, we are already written s in centimeters square, so we don't have to mention the units. Now in question 3, we have to expand this term over here and find the first 4 terms in ascending powers of x. If we expand this, we'll have 2 to the power 7 as our first term. Then we'll have 7c1 times 2 to the power 6 times kx by 8 to the power 1. The third term will be 7c2 into 2 to the power 5 into kx by 8 whole square. And the fourth term, the last we need to find, would be 7c3 times 2 to the power 4 times kx by 8 to the power 3. The first term expands to be 128. The second term comes out to be 56 kx. The third term comes out to be 21 by 2 k square x square. And the fourth term comes out to be 35 by 32 k cube x cube. We don't write the other terms, we just write a plus and then give 3 dots to indicate that there are other values which we are not writing. Now in part B, we are given that in the binomial expansion of f of x, the coefficient of x, x square and x cube are the first 3 terms of an arithmetic progression. So we have to find the possible values of k. For an arithmetic progression, the difference between the first and second term should be equal to the difference between the second and third term. So 21 by 2 k square minus 56k should be equal to 35 by 32 k cube minus 21 by 2 k square. If we take everything to the right, we'll have 0 equals to 35 by 32 k cube minus 21 by 2 k square minus 21 by 2 k square plus 56k. We can take k common. We can take 1 by 32k common to remove this denominator over here. So we have 35k cube minus 336k, sorry, it would be minus 672k plus square plus 52 plus 1792. Okay, we are taking a k common out here, so this will be squared, this will be k to the power 1, this will be equal to 0. Now we can solve the quadratic. Before doing so, we can take a 7 common out from here as well. We'll have 5k square minus 96k plus 256 equal to 0. Then we'll have 77 by 32 k times 5k square minus 80k minus 16k plus 256 equal to 0. From here we get 7 by 32k, 5k minus 16 times k minus 60. We could show one more step in between, so we'll have 7 by 32k. We take 5k common, we get k minus 16. We take minus 16 common, we get k minus 16. From here we know that the values of k is 0, 16 by 5 and 16. K cannot be 0. We are given that k is a non-zero constant, so we ignored this value. So these are the values of k. K can be 16 by 5. Now in question 4, we have to solve this logarithmic equation using the laws of logarithms. At first we'll have log 4x base 3 plus, instead of 2, we need to introduce another thing with log base 3. We can write this as 2 times log 3 base 3. We can use this because we know that if we have log b base b, it will always be equal to 1 if b is not equal to 1 or greater than 0. If b is not equal to 1 and greater than 0, not all. And in this side we have log 5x plus 7 base 3. We can move this 2 as a power of 3 over here. So we have log 3 square base 3 or log 9 base 3. This is equals to log 5x plus 7 base 3. If logs are added, we can multiply this over here, so 4x times 9 base 3. If they have the same base and they are added together, we can multiply the top and combine them into a single logarithm. From here we can cancel the log base 3 out. We'll get 4x times 9, which is 36x. This will be equal to 5x plus 7. So 36 minus 5, 31x will be equal to 7. X will be equal to 7 by 31. Now in part 2, we are given that summation of log base a of y to the power r is equal to log y base a whole to the power r. We have to find y in terms of a. We have summation of r equals to 1 to 2 of log y to the power r base y The first term would be log y to the power 1, so log y base a, plus the second term would be log y square base a, and the other one on the right hand side we have summation of 2 r equals to 1 of log y base a to the power whole to the power r. This is log y base a plus log y base a whole square, and we know both of them are equal to each other, so we can write down log y base a plus log y base a whole square is equal to log y base a plus 2 times log y base a. We can consider z, another variable, as log y base a. We'll have z plus z square equals to 3z. We can move the 3z to the left, we'll get z square minus 2z equal to 0. We get z times z minus 2 equal to 0. So the critical values are z equals to 0 and z equals to 2. So we get log y base a equals to 2. We cannot consider 0 over here, since we are given that y is greater than a and a is greater than a. Y and a are both greater than 1, and y cannot be equal to a, so we cannot have 0 over here. So from here we need to find the relationship between y and a. If we break the log down, this notation simply means that if a is raised to the power 2, we get y. So this is the power, this is the base, and this is what we get if we raise the power to the base. So we get y if we have a raised to the power 2. So a square is equal to y. This is the relationship between y and a we had to show. Now in question 5, we are given a cubic equation, and we are given that x minus 3 is a factor. From there we have to show 9p plus q is equal to minus 51. If x minus 3 is a factor, f of 3 would be equal to 0. If we put 3 into here, we get 3 cube plus p plus 3 times 3 square minus 3 plus q is equal to 0. 3 cube is 27. We have p times 9 over here, so 9p plus 3 times 9, 3 square is 9. 3 times 9, we have 27 minus 3 plus q. So 9p plus q plus 27 plus 27 minus 3 plus 51 is equal to 0. So 9p plus q is equal to minus 51, and this is what we had to show. Now in part B, we are told that when f of x is divided by x plus p, the remainder is 9. So f of minus p is equal to 9. So minus p cube plus p plus 3 times minus p square minus p plus q is equal to 9. So minus p cube we have p times minus p square is basically p square, so we have plus p cube plus 3p square plus p plus q equals to 9. We can move the 9 to the left. Minus p cube and plus p cube cancel out, we get 3p square plus p plus q minus 9 is equal to 0. This is what we had to show. In part C, we have to find the value of p and q. We are given two equations, so this is equation 2, this is equation 1. If we subtract equation 1 from equation 2, we can get rid of the q. So we get 2 minus 1. So 3p square plus p plus q minus 9 equals to 0 minus 9p plus q. Equal to minus 51. We can move the 9 over to the right to match the second equation. If we subtract this, this will be minus, this will be minus, this will turn to plus. So we have 3p square plus p minus 9p, so minus 8p. The q's cancel out, and on the right we have 51 plus 9, which is 60. So 3p square minus 8p minus 60 equal to 0. We have 3p square minus 18p plus 10p minus 60 equal to 0. We can take 3p common over here, we get p minus 6. We can take 10 common over here, we get p minus 6. So we have 3p minus 3p plus 10, p minus 6 equal to 0. We get p equals to minus 10 by 3 and p equal to 6. However, we are given the conditions that p and q are constants where p is greater than 0. So p must be greater than 0, so we ignored this 10 minus 10 by 3. So p must be equal to 6. And if p is equals to 6, 9 times, so 9p plus q is equals to minus 51. I'll put the value of p over here, so 9 into 6 plus q is minus 51. From here we get the value of q, which would come out to be minus 51 minus 9 into 6, which is minus 105. Now in part D, we have to find a quadratic expression g of x for which f of x is equals to x minus 3 g of x. So the value of p we got is 6, so this is 6 plus 3. So f of x would be x cubed plus 9x squared minus x. We have the value of q, which is minus 105. This is f of x. And we have to find the expansion g of x such that f of x is x minus 3 times g of x. So f of x on the left is equal to x minus 3 times g of x. So g of x would be x cube plus 9x square minus x minus 105 divided by x minus 3. Here we can use long division. So the numerator is x cube plus 9x square minus x minus 105. The denominator is x minus 3. We have x square over here, x cube minus 3x square. This we have 12x square minus x. We can take plus 12x. $35x minus 105, put in plus 35, we get 35x minus 105, we get no remainders. So f of x is equal to x minus 3 times x square plus 12x plus 35. This is g of x. This part over here is g of x. So g of x is x square plus 12x plus 35. Now for question 6, we are given that a circle with equation x square plus y square plus 8x minus 4y equals to 0. We have to find the coordinates of the center and the radius. So we have to complete the squares over here and find the equation in this form. So x minus a square plus y minus b square equals to r square, where the center of the circle is a comma b and the radius is r. To do this, we have to complete squares for the expansion, for the expression we are given. So we are given x square plus 8x plus y square plus 4y minus 4y. We'll separate the y and the x at first. Now if I complete the squares for x, we get x plus 4 whole square minus 4 square, and if we do it for y, we get y minus 2 whole square minus 2 square equal to 0. So x plus 4 whole square plus y minus 2 whole square minus 4 square minus 2 square, which is minus 20 equal to 0. We can send the 20 to the right, we'll get this is equal to 20. So the coordinates of the center would be minus 4 comma 2. The radius would be equal to root over 20. Or root over 2 root 5. Now for part B, we are given that point P lies on C, and given that the tangent to C at P has the equation x plus 2y plus 10 equals to 0. We have to find the coordinates of P. We are given the equation x plus 2y plus 10 is equal to 0, and this lies on the circle. From here we can make x the subject. We get x is equal to minus 2y minus 10. Since this falls on the circle, we can use x equals to x or y equals to y. By doing that, we can just put the value of x in place of the circle's equation. We'll get minus 2y minus 10 whole square plus y square plus 8 times minus 2y minus 10. I'm using this expression over here since it makes the working easier. If we had a whole square, it would be more painful to work with. From here we get 2y whole square is 4y square plus, the sign does not matter over here since it's squared, so even if we had a minus 2y plus 10 whole square, the minus would disappear. When we expand it, we'll get 4y square plus 2 into 10 into 2, so plus 40y plus 10 square is 100 plus y square plus 8 times minus 2 is minus 16y, and 8 times minus 10 is minus 80. We'll get 5y square plus 40 minus 16 minus 4, 5y square plus 20y plus 20 equal to 0. We can take 5 common over here. We'll get y square plus 4y plus 4 equal to 0. We can write this down as y plus 2 whole square equal to 0. So y is equals to minus 2. Using that, we can find the value of x. X would be minus 2 times minus 2, the value of y minus 10. Minus 2 times minus 2 is 4 minus 10. We get minus 6. We have to find the coordinates of p, which would be minus 6 comma minus 2. Now in part C, we have to find the equation of the normal to C at point P. From the equation of the tangent, we can find the gradient of the tangent. We had x plus 2y plus 10 is equal to 0. We can rearrange this in the form of y equals to mx plus c. If we do that, we'll get 2y equals to minus x minus 10, y is equals to minus x by 2 minus 5. So gradient of the tangent is minus half. The tangent and normal are perpendicular to each other, so if we multiply their gradients, we'll get minus 1. We already know the gradient of the tangent to be minus half. We want to find the gradient of the normal. The product would be minus 1. So gradient of the normal, we can cancel the minus out. This will be 1 divided by half, which is equal to 2. Now we also know the coordinates of p, which is minus 6 comma minus 2. So this is x1, this is y1. We'll use the equation y minus y1 equals to mx minus x1. We'll have y minus minus 2 equals to 2 times x minus minus 6. So y plus 2 is equals to 2 times x plus 6. So y equals to 2x plus 12 minus 2. Y is equals to 2x plus 10. Now moving on to question 7, we are given a geometric sequence with first term a and common ratio r. We know that the third term is 20, fifth term is 12.8. We have to show that r is 0.8. The first term is a, the second term would then be ar, the third term would be ar square. So the nth term would be ar to the power n minus 1. Since the first term has r equals to 0, r to the power 0, the second one has r to the power 1. So the power of r is 1 less than the number of term it is. The third term is ar square, this is equal to 20. And the fifth term is ar to the power 4, this is 12.8. If we divide this 2 by 1. If we divide equation 2 by equation 1, we'll get ar to the power 4 divided by ar square equals to 12.8 by 20. The a's cancel out, the r square cancel out, leaving r square equals to 12.8 by 20. So r square is 0.64. R would be plus or minus root over 0.64. Now we know that r is greater than 0, so we do not need to take the negative answer. So r is equals to 0.8 shown. And hence we have to find the value of a. So we can put that in equation 1. We'll get a times 0.8 square equals to 20. A would be 20 by 0.8 square. We'll get a value of a which is 31.25. Now in part C, we are given that the sum of the first n terms of this sequence is greater than 156. We have to find the smallest possible value of n. So S summation of up to n. The equation of the sum of the first n terms for a geometric sequence is given by this formula over here. So a 1 minus r to the power n divided by 1 minus r. In this case, this must be greater than 156. The value of a is 31.25. 1 minus 0.8 to the power n divided by 1 minus 0.8. We can cross multiply over here. We get 31.25. When we have an inequality, when we cross multiply, we go like this. So this stays on the left, this diagonal stays on the left, this diagonal goes to the right. So we have 156 by 1. This diagonal stays on the left, the blue diagonal stays on the right. So if we have a by b greater than c by d, we have this diagonal over here on the left, so AD is greater than BC. If we apply it over here, the red diagonal will be on the left, so 156 into 1 minus 0.8, which is 0.2, is less than 31.25 times 1 minus 0.8 to the power n. We can move the 31.25 to the left, so we have 156 into 0.2 divided by 31.25, which is less than 1 minus 0.8 to the power n. So we get 1 minus 0.8 to the power n is greater than 0.9984. So we can write down 1 minus 0.9984 is greater than 0.8 to the power n. So 0.8 to the power n is less than 0.0016. Now you need to be careful when we take log on both sides. If we have a value less than 1 over here, the sign will flip, because log 0.8 So anything for log base anything which cannot be x, so log base b cannot be 1, b has to be greater than 0 as well, and x which is less than 1 more than 0. So if x is within this range, this value over here is negative. So if this positive value turns negative, the sign will flip. This value will also turn negative since this is also less than 1. So both values will become negatives. So the sign will flip over here. So we have log 0.8 base 0.8 to the power n. We can take the n over here, less than log 0.0016 base 0.8. This thing over here is 1, so we have n less than log 0.0016 base 0.8. we get n is less than 28.9. So the smallest possible value of n would be, sorry, the sign flips, I forgot to. So n will be greater than 28.9. So the smallest value of n will be 29. Now moving on to question 8. We are given this equation over here, and we have to give our answers in radians to 2 decimal places. For solving such questions, we have to ensure that our calculator is in radian mode. We'll get 5 sine 3x plus 0.1 is equal to minus 2 sine 3x plus 0.1 will be equal to minus 2 by 5. Since sign is negative, the answers will be in the third and fourth quadrant where sign is negative. We have to change the range, since we are given the range for x, not for 3x plus 0.1. So for x, the range is minus pi by 2 to pi. For 3x, it would be minus 3 pi by 2 to 3 pi, and if we are adding a 0.1 to it, we get 3 pi by 2 plus 0.1, which is minus 4.61 less than 3x plus 0.1 less than 3 pi plus 0.1, which is 9.52. The basic acute angle from here would be sine inverse 2 by 5. We are not gonna take the negative when we are finding the basic acute angle. Since we want our answer to 2 decimal places, working with 3 decimal places over here should be fine. So the basic acute angle is 0.411 radians. Now if we go for the positive rotation, our value of 3x plus 0.1 can be pi plus 0.411, 2 pi minus 0.411, and if we go in the negative axis, so instead of rotating like this where we rotate into the positive axis, we'll rotate opposite to it. So we'll rotate like this. If we rotate like this, so this is minus basic acute angle, this is minus pi minus basic acute angle. This is minus pi plus basic acute angle. This is minus 2 pi minus basic acute angle. So the other two values we'll get are minus 0.411 and minus pi minus 0.411. So 3x will be pi plus 0.411 minus 0.1, 2 pi minus 0.411 minus 0.1, minus 0.411 minus 0.1, and minus pi plus 0.411 minus 0.1, and x will be that divided by 3. So if we calculate that, so pi plus 0.311 by 3, 2 pi minus 0.511 by 3, minus 0.511 by 3, minus pi plus 0.311 by 3. So the first value comes out to be 1.15. The second value comes out to be 1.92. The third one comes out to be minus 0.17, and the last one comes out to be minus 0.94. Now in part 2, we have to solve the equation 2 tan sine theta equals to 5 plus cos theta in degrees. Remember to change the calculator mode back to degrees. We have 2 tan theta sine theta equals to cos theta plus 5. If we multiply both sides with cos theta, we'll get 2 cos theta tan theta. Now we know that sine theta by cos theta is equal to tan theta. So if we make sine theta the subject, sine theta is equals to cos theta times tan theta. This is what we have over here. So this can be written down as sine theta. We have another sine theta over here. If we multiply the right hand side with cos theta, we will get cos square theta plus 5 cos theta. To spot this, you need to remember this identity and the other one, which is cos theta equal to sine theta by tan theta. So you need to remember both of this. So this is 2 sine square theta equals to cos square theta plus 5 cos theta. Now we can write sine square theta as 1 minus cos square theta. So 2 times 1 minus cos square theta equals to cos square theta plus 5 cos theta. We have 2 minus 2 cos square theta equal to cos square theta plus 5 cos theta. We can move the terms on the left to the right. We'll have 0 equals to 3 cos square theta plus 5 cos theta minus 2. We can solve this quadratic directly. We'll have 0 equals to 3 cos square theta plus 6 cos theta minus cos theta minus 2. If this feels If you don't feel comfortable working this as a quadratic, you can hold something like this. So y is equals to cos theta. So instead of y, we'll write y square. Instead of cos theta, we'll write y. So solve it like this. Doing it with cos theta will give you the answer faster. So I'll do in that method. So we get 0. We can take 3 cos theta common over here. Get cos theta plus 2 minus 1 cos theta plus 2. So we get 0 equals to cos theta plus 2 and 3 cos theta minus 1. We get the values of cos theta to be minus 2 and cos theta to be 1/3. The range of cos is from minus 1 to 1, so we cannot get minus 2. So cos theta must be 1/3. It's in the first or fourth quadrant. The range is 0 to 360 degrees. So the basic acute angle over here would be 70.5 degrees. They want to 1 decimal place, so we'll find this to 2 decimal places. So this is 0.70.53. So the values of theta would be 70.53 and 360 minus 70.53. So theta will be 70.5 and 289.5 to 1 decimal place. Now moving to question 9. We are given the equation y is equals to x square minus 4x plus 5 and y is equals to 2. We know that the curve C intersects the y-axis at the point D. So at point D, x is equals to 0. So this is 0, this is 0. So this would be plus 5. So the coordinates of D would be 0, 5. Now in part B, we are given that curve C intersects the line L at the points E and F. We have to find the x coordinate of E and the x coordinate of F. This is E, this is F. We can set y is equals to y. So for B, y is equals to y. So x square minus 4x plus 5 is equals to 2. So x square minus 4x plus 3 is equals to 0. X square minus 3x minus x equal plus 3 is equals to 0. We can take x common, x minus 3, and we can take minus 1 common, we get x minus 3 again. So we get x minus 3 times x minus 1 equals to 0. So the value of x can be 3 or 1. E is to the left, so it has a smaller value of x. So E has coordinates. So at E, x equals to 1, and at F, x equals to 3. Now we are told that in figure 3, the region R1 and R2 are shown. R1 is bound by the curve, the line, and the y-axis, and the region R2 is bounded by the curve and EF and DF. So this line and this line, or this section of the curve. df is this, so this line over here. We have to find the ratio of area 1 by area 2, which is equals to k. We have to find the exact value of k over here. This is a 5-mark question, so pretty big. So at first we can find the area R1. This is we can get this by integrating the area of the curve from x equals to 0 to x equals to 1, and then subtracting this rectangle from it. If we integrate, we get the area up to the x-axis. So this is the area we find if we integrate, and then we have to subtract this rectangle from it to get this area R1. So area R1 would be equal to the integration of x square minus 4x plus 5 dx from 0 to 1 minus, if we want to find the area of this rectangle, this is, the height is 2 and this length over here is 1, so this would be 2 into 1. Now if we integrate this, we get x cubed by 3 minus 4 by 2 x square plus 5x from 0 to 1 minus 2. We get 1 by 3 minus 2 plus 5 minus 2. So this area comes out to be 4 by 3. Now we need to find area R2. There are two ways we can go about it. The simpler way, according to me, would be to integrate the area of the curve from D to F, so from 0 to 3, from x equals to 0 to x equals to 3, and if we do that, we find, my bad, no. We can find the area of this whole triangle, this triangle over here, and then we can subtract area R1 over here. So this is the simpler of the two methods. So area R2 would be, this is 3, this is 5, this is 2, so this is 3 as well. So half into 3 into 3 minus area R1, which is 4 by 3. We get a value of 19 by 6. The other method would be a little tougher. That method, in that method, we have to find the equation of line DF, and then we have to integrate that line's equation. So I can write L1 is the equation of the line minus the equation of the curve C dx from 0 to 1. That would give you this whole area. Sorry, if we do it 0 to 1. If we didn't do 0 to 1, we'd get this area additionally. It's harder to subtract this, so we do it up to 1. So we find this area, and then we add the area of this triangle. This is 2, this is also 2. So this is much tougher. We don't have to go this way. We don't need to overcomplicate simple stuff over here. And now we have to find the ratio of area R1 to R2. So A of R1 divided by A of R2, which is 4 by 3 divided by 19 by 6. If we calculate this comes out to be 8 by 19. Now in question 10, we are asked to prove by exhaustion that if n is an integer, then 2n square plus 2n plus 1 is not divisible by 3. This is what a student did. He considered the case where n is a multiple of 3. So we had 2n square plus n plus 1. We replaced it with 18k square plus 3k plus 1. We could take 3 times k square plus k plus 1 common out here, and we could show that this is not divisible by 3. Since this part is divisible by 3, if we add 1 to it, it will not remain divisible by 3. The other two cases we could have would be when n is 3k plus 1 or when n is 3k plus 2. If n is 3k plus 3, it's basically the next multiple of 3. So it's the same thing as 3k. Since k is a variable over here, instead of 3k minus 2, we could also write 3k plus 1 and 3k minus 1. So 3k's, if we draw a number line, we have 0, 1, 2, 3, 4, 5 and 6. 3k basically means any multiple of 3, so it could be 3 or 6. So 3k plus 1 is 1 next to it, so 4. 3k plus 2 is 2 to the right of that value. So if we take k equals to 3, 3k plus 1 is 4, 3k plus 2 is 5. Instead of that, we can also write 3k minus 1 and 3k plus 1 and omit 3k plus 2. From here, we can get the same two values. So if we had 3, we can take k equals to 3. So 3k plus 1 would be 4. We could also take k is equals to 6. Sorry, 3k equals to 6. So 3k minus 1 would be 5. We could do either way, whichever is easier for us. So when n equals to 3k plus 1, we'll have 2 times 3k plus 1 whole square plus 3k plus 1 plus 1. If we expand the whole square, we'll get 9k square plus 6k plus 1 plus 3k plus 1 plus 1. We have 18k square plus 12k plus 2 plus 3k plus 1 plus 1. We can take 3 common over here. First, let me write the terms together. We have 18k square plus 15k plus 3 plus 1. We can take 3 common out from here. So we have 3, 6k square plus 5k plus 1 plus 1. This is divisible by 3. So this whole term will not be divisible by 3. This is not divisible by 3. We can also imagine this as a number line. So 1, 2, 3, 4, 5, 6. So this is a multiple of 3. So something like 3 or 6. If we add 1 to it, this will become 4. 4 is not a multiple of 3. If this whole term was 6. 6 plus 1 would be 7. This is not a multiple of 3. So it would be more than a multiple of 3. We can also think about it in another way. Multiples of 3 occur after every 3 values. So this gap over here is 3. This gap over is 3. So if a value falls in between that, so if we add 1 or 2 to a multiple of 3, it will not be a multiple of 3. It will be values like 1, 2, 4, 5, 7, 8, 10, 11, values like those which are not multiples of 3, which falls between the multiples of 3. So this is shown for 3k plus 1. Now for 3k plus 2, we'll have 2 times 3k plus 2 whole square plus 3k plus 2 plus 1. Here we have 3 times 9k square plus 3 2s are 6, 6 2s plus 12k plus 4 plus 3k plus 2 plus 1. This is 18k square plus 24k plus 8 plus 3k plus 2 plus 1. We want, so if I write this, so 18k square plus 24, 25, 26, 18k square plus 27k. If we add 8 and 2, we'll get 10, so we cannot take that as a multiple of 3. So we can just add 8 and 1 over here, so we'll have plus 9 plus 2. This whole thing can be, we can take 3 common out from this 3 terms. So we have 3 times 6k square plus 9k plus 3 plus 2. Due to this plus 2, this is not divisible by 3. So for all 3 possible cases, this is not divisible by 3. So hence 2n square plus n plus 1 is not divisible by 3 if n is an integer.